16 of the smartest minds in America today. You have come to this meetup. Your midweek event is going to be awesome. My name is Tarek Lewis, and you can consider me your cruise director, but more so than that, your co-organizer. And I am going to hand off to Rob Durst to tell you a little bit about who we are and why we do this. Rob.
Awesome, thank you. I've never done this before. Too fast. Alright, so that's us. We got Tarek, Rob, even though Nelly hasn't been here for weeks. So yeah, this is kind of the gist of our group. Basically, we think there's a need for one more developer-focused cryptocurrency meetup. The general gist of this meetup is that you all are developers, and everyone who presents is showing a technical presentation. The idea that most meetups around here don't do this, and so this is kind of a niche that's really interesting. We're focused across all cryptocurrency technologies, Bitcoin, all those, XLM. We have high-quality technical presentations. And we do have a manifesto. Essentially, one, we focus, like I said, only on deep technical presentations. Two, we're all about peer-to-peer learning and exploration. Three, strictly engineer-focused content. We'll never have an ICO pitch ever. Four, we help others learn, so we all learn. And five, the most important one is respect all community members. So yeah, this meetup wouldn't have come together if it weren't for someone telling us about IoTeX. We get most of our best ideas not from myself, not from Tarek, but from the community. So if there's an up-and-coming project, tell us. The best way to do so would be on the Telegram channel. And yeah, also something else that's super cool. I don't know, was anyone here for the Block and Jerry's presentation? Yeah. No? Okay.
Yeah, I was.
You all messed up. But anyway, if you're working on something super cool and you want to present, talk to us. And we have a bunch of lovely sponsors, one being IoTeX. Let's give them a round of applause. We also have Abra, Decentraland, Mobius, Zcash, Enigma, TokenSoft, Aragon, and Kilo. So here are upcoming events. In a few weeks, we'll have Abra come present on building price-stable synthetic currencies. And something else you can present on, which isn't here, is I think they have a multi-sig wallet. That's right. For those who are kind of new in this space, a lot of people will claim and talk about multi-sig, but there's no actual nice UI for it for multi-sig. So that should be super exciting. And another one which I'm super excited for is, and I don't know much about this one, but
smart contracts with Clemens. He used to be at yours, a founder, and so he's now starting his own thing where he wants to actually show you can build smart contract engines that are Turing complete in Bitcoin.
Sounds awesome. Cool. So yeah, so let's get to it. So today we are going to talk about IoTeX. And has anyone read the white paper? Do we distribute? Top secret? Yeah, anyway, it's super cool. These guys are working on a lot of cool things, and I probably would butcher if I tried to explain it. So without further ado, we have Dom from IoTeX. Woo!
Hey guys, how's it going?
Yay! Can you get over that?
Bigger space. Do you want us to move it? Yes, just do it. Is this good? What do you want?
Yeah, we are a team based in Nova Park, which is our.
You should probably stand on this side.
Yes.
Why don't you stuck under the wire?
Okay, good.
And then you can put that back where it was, Tarek.
You want me to?
Turn it. There you go. Perfect. We're done.
Oh, that's right. Yeah.
You guys are professional.
You really are right.
Someone's got to tell them what to do.
Yeah. Our office is not very far from here, but it's been 2 hours for us to get here, thanks to the traffic. But also, luckily, we only started at 7, and we got some parking here. Yeah.
pretty good. I know this space. I have been here a few times. Not this particular place, but this area. Each time it's really hard for me to find a parking. Yeah. Okay. Hey, I'm Dong. Thanks for coming to our meetup. We are IoTeX, auto-scalable, privacy-centric blockchain for Internet of Things. So today's agenda, I'm going to talk about what is IoTeX, and we will have Zhijie to talk about the RDPoS, our in-house consensus model, and do key skill surveys. That is a research paper we just published in a research academic conference. Before getting into details, let me introduce all speakers. First of all, me. I did PhD in machine learning and computer vision in National University of Singapore. Before starting IoTeX, I was at Facebook. And while I was spending a very long period, over 7 years at Facebook, I also did some angel investment and advised a few startups. And Xinxin, who is taking a picture of me right now, is a PhD in cryptography from University of Waterloo. And before joining the team, he was in Bosch, and he did 40 years of research in cryptography and had over 40 publications. And Zhijie, he was at Facebook before joining Facebook. He also got his PhD from National University of Singapore. And he did a lot in P2P networking and database in the past. He was before Facebook, he was at Hortonworks. So we will have 3 speakers, and we have a relatively good size of audience. We have a good ratio today. So starting from what is IoTeX, we all know Internet of Things has huge potential in the future. According to a lot of different research, it could be even $1 trillion market in next 2 decades. It's not one asset, it's according to some research report. And even right now, there are many applications and around us that are powered by IoT, including like a projector, speaker, and different things. Whenever they connect to the internet, they are considered an Internet of Things. And there could be even more and more. Do we have a pointer here? Okay, that's good. Yeah, that's good. Yeah. So you can see around you in your home there are quite a different type of IoTs, and in your offices and factories, and also work site, outside in the city, in the vehicles, you can see a lot of different type of IoTs. And oh, by the way, can I do a quick poll? And how many have you guys bought Bitcoin or any other coin or tokens? Sweet. Everybody has this kind of context. And how many of you are actual developers? You're actually coding. That's good size. Yeah. Luckily, we prepared just for developers today. We are not going to go through a lot of marketing details. And this is the only slide we are doing that. And IoTeX. IoTeX bring trusted machine economy to IoT. What does it mean? IoTeX bring trusted layer. All the IoT devices, they can trust each other. The data provided by the IoT devices are trusted. The network is trusted, so they can safely connect to each other and coordinate with each other. Decentralization. No one is going to manipulate the data and control the data and make use of the data unless you permit. And token incentive. Different project or companies, and in the future it might be just projects, not the companies in the future. And they can provide token incentive. They can have their own blockchain and having total incentive to incentivize all the users and the developers to work on to use their product. Privacy. Privacy is the key feature. Without privacy, IoT cannot connect. Most people are not comfortable about getting their IoT devices to connect to the blockchain because right now currently most blockchains are very open and transparent. Their data, all the data are public. Whenever they know your wallet address, they know everything. And if all the IoT devices are actually related to people, like your personal life, your car, and also your health data. If they're connected with the blockchain without any protection, that would be a disaster. And this is what IoTeX can solve the current problem that IoT systems. And on the privacy side, I just mentioned a little bit, but in the current stage, all the data are stored in the cloud, and the cloud being controlled by certain giant companies, and they, like Facebook, for example, Google, Amazon, and also they are also stored in a particular data center. And you have never know how they protect your data. There might be some problem that they didn't protect well and they been leaked. And also they can for sure use your data for some purpose without even letting you know. And we did a lot on the privacy protection. Yeah. Later, Qingjin will present the paper that how we protect the data on the blockchain. And scalability and availability. When IoT startups, when they operate their IoT on the cloud, the operation cost grows exponentially with the size of the IoT devices. The management cost is very high. And also, most IoT companies, they are hardware driven. They are not very familiar with software. Scalability can be a pinpoint for them. And availability. And when you, as a user, when you buy a product, you expect it can run forever, unless the product is faulty and dies sometime. But sometimes the company can even go bankrupt even before your hardware your hardware is dead. That means all the cloud will be shut down, and you wouldn't even use the hardware. I have personal experience on this. Like when I bought all the camera, I searched online, and that company I have never heard about it, and I couldn't buy because it's very likely that the company might pivot and bought, and so that their service can be shut down. And without the cloud, it's nothing. But we can bring the availability to this type of devices. Interoperability. The current way how it works is the devices are connected to the cloud, and the different clouds talk to each other somehow. But this is but reality is most of the clouds do not talk to each other. Like Google never talk to Amazon, and they also set some barrier for other people to enter. And as a result, it's really hard for all devices to be connected. And with the open source project, everyone can contribute to it. Everyone can connect to it. At least this is such a new way for us to bring all the connectivity to all the devices. This is how we can solve existing IoT problems. And but what we are looking for is even how we can actually bring new economy when we get IoT and the blockchain together. This is how we lay out. So IoT blockchain is IoTeX blockchain. We build we call it the Notion. This is architecture-wise, and we also build the SDKs, share SDKs for all the developers, companies to build their own blockchain. In the system, we call it a subchain. And there could be one blockchain for shared economy, one for smart home, one for automated vehicles, and one for subchains. And on top of those subchains, there could be DApps and modules. DApps, we can talk to one chain or multiple chains, and bring different functionality together, and that can connect to different devices. And modules, they can enhance the different assumptions. And for example, like Edge AI, it doesn't have to be a blockchain which kind of like solving the app problem. It will be a module that listen to the chain and get the data and get back to the chain so that other devices can act based on the results. This is how we lay out the structure. And you can also think this way, how we, sorry, I have another, yeah. The difference between having the IoT plus the blockchain to initiate a new economy, you can think this way. Some of the, there's one example, like sharing Wi-Fi. You can think about this way. If there's a router company build a blockchain that can share the Wi-Fi to everybody, so that whenever people are using their phone and laptop, they can just use others' Wi-Fi. And this can be totally autonomously done on the blockchain. It doesn't have to be like anyone in the middle. They're not going to be kind of a company who are saying, okay, let me connect, let me buy all the routers, let me also like start this kind of business, and then I can make it perfect by providing ads and different things. This is the old business model. And in the new one, when you have the token economy, when you have the blockchain, you can get the community to contribute, and also get the community to contribute to sharing their devices out. And any questions so far?
Yeah, quick question for you.
Yeah.
When we think of the devices, we go back to your prior slide. When we think of the, we go back one more into interoperability. When we talk about interoperability in IoT, are we talking about also IoT devices that may be controlled by large conglomerates like telephone companies, for example, at Verizon, which controls most of the IoT devices that may be seen, or control the networks that connect these IoT devices?
So we are thinking more forward. When it can, we are not talking about the IoT devices talk to the cloud and then talk to blockchain. We would like all the IoT devices directly talk to blockchain. That means they probably can have two modes, and one mode they can talk to the cloud, one mode talk to the blockchain. And talking to the blockchain, they can definitely listen to the data from the blockchain so that they can talk to each other.
Awesome. And will you need to negotiate providers to get your software onto their firmware? Given that, or to get your software onto these IoT devices, is that something that's going to be part of interoperability, or is that something else?
Maybe I think we would go for like getting the manufacturers directly building new products that can talk to each other. For the existing ones, it's really hard for them to only upgrade their hardware. Probably they can, but it's not a very good instinct for them to do that.
Follow up. So is this your own protocol? Is this your own design of like format standard for taking the data, the structure of the data that the IoT device would be sending? Right now, there's so many standards, right? That the IoT devices, the way the IoT devices generate the data. That's one of the issues, is that nobody can talk to each other because the way the data is generated is not standardized.
Yeah, that's a good question.
Yeah. So many standards that it's not standardized.
That's a good question. I think the way how to do it is getting all the community members also to define the ways so that they can talk to each other, not having someone they can be somehow powerful and they define some format, and another powerful party define another standard. That they wouldn't talk to each other. But on this kind of like a collaborative way, and on the blockchain, they can actually do that. And also, you can think about this way. When we have different substrates, and different substrates, they can have their own standard. But however, when we are designing the cross-chain communication, that can be also like there can be some connectors for them to release the data, and so that to the format everyone can understand, so that it can be standardized.
Have you picked the format for your system?
Yeah. So right now we are working on the blockchain side. Yeah, we haven't get into that stage that we have to force the different parties to talk to each other yet. And also, I think I think in the future, the first steps would be getting those type of like projects or companies to start doing this, and then at the same time we should figure out we should have a way for different people to have the improvement plan to get the standardized.
That's a good point. I would say that he's building an IoT blockchain, I know that, and I'm building an IoT blockchain, right? So what we're going towards is a world where there are, instead of several standards, several IoT blockchains. And we're basically going to repeat the problem that exists.
But the good thing is, all of your blockchains are open, and everybody can contribute, so that if you go to the way that they can talk to each other. It's not like you are, because you have a blockchain, it's not like you have a cloud. You do not even let other people connect. In that way, you can never reach such a consensus.
One more question.
Sure.
What would be the cost? Have you estimated what's the cost of basically sending the data and communicating the data? Right? If you're looking as a comparable to building something on top of Ethereum, is incredibly expensive. Yeah. So we thought about that. Our considered model is improved version of EOS. So that it's sort of a default, but we improve that. We will come up, we will introduce that later. Yeah. So the cost would be much lower than Ether for sure, but there are still some cost for sure because of blockchain, because of nature of blockchain, and you gain something, you also need to pay for it a little bit, and also because there is no cloud, so that someone has to pay for the miners. So do you know if the supernodes themselves maintain the ledger?
Say again, sorry?
The supernodes, the master nodes themselves would maintain the ledger?
Yes. We'll get into details later. Yeah.
That's your delegated proof of stake we're going to talk about soon, right?
Yes.
Let's get to it.
Yes. Get to it quickly.
Yeah.
Yeah. So how do we make it work? We call it RDPoS. This is an in-house business model that we have randomized the delegates proof of stake. So which means we have a large pool of the delegates, and then for each we call epoch, and we have random selected delegates to be the block producer. This is our improvement, but technically it's also it's still very hard. Yeah, we are going to get details how do we make it work. And we also have privacy preserving algorithm, and we have three different techniques to provide the sender, receiver, and also the data itself. And we also have a blockchain architecture. That is what we call it auto-scalable. That because no matter how you improve the blockchain, and you still cannot reach you still have the risk to reach the moment that when the nodes connecting to the blockchain is too many, and the transactions they are sending are too many, you basically still get jammed. And recently there's another app on Ethereum called Form 3D that makes the all transaction really high, and people are suffering from that. And having this kind of like a blockchain, everybody can create their own blockchain, but in architecture it's called subchains. And so it's kind of like auto-scalable, and also the delegates pool will also auto-scale based on the number of the subchains. Go ahead, yeah.
Is the subchain architecture analogous to sidechains in Bitcoin or other blockchains?
Yeah, I think it's a little bit different because the subchain itself is a fully functional blockchain. It's also very decentralized. And when we have all this architecture, another one we are thinking is autonomous device coordination. And this is more related to the smart contract. So we are also designing smart contracts that can talk to different subchains, so that all devices, when they connect to different subchains, they can use smart contract to get connected. So basically the DApps can actually run in this way. Okay, I would talk a little bit more about the blockchain functions architecture, and Zhijie will get into the RDPoS. So this is the overall architecture, how it works. We have the root chain in the middle, that is a very lightweight blockchain, and the main purpose for this blockchain is to hold the tokens and also do the subchain governance. And for the subchains, there could be different kind of settings, including the privacy settings, including like other advanced features that we may introduce in the future. And all the devices will connect to the subchain instead of the root chain. And the subchain can talk to another subchain, either related by the root chain, or in the future we might also design some algorithm for them to talk to each other directly. And also, I'll give a little bit introduction about this as well. Think about this diagram, and all the devices are, when we are thinking how the blockchain can connect to the real world, IoT devices are really a good way. Because the IoT devices, when you put in some secure model there, and all the data can be trusted, and all the data they recorded can get back to the blockchain securely and trustedly. And devices, they also listen to the event on the blockchain so that they can react based on the blockchain results. Like I said earlier, if there are some modules that can modify the blockchain in certain ways, and the device can also react based on that as well. This is coming in a loop. And the devices can also either propagate the data to the subchain, and or maybe they can use the blockchain to buy some resources for them to use, like bandwidth, like storage, like other things. So all of them together as a loop, they can be considered as what we are talking about as autonomous device coordination. Any questions on this one? Yeah. Right.
What measures have you tested to validate the security and safety amongst autonomous devices that are shared? You know, and how do you know it's proof? How do you know it's that secure? I mean, you're speaking very confidently on that. Security.
Yeah.
What have you done to that's
yeah, the secure part. Yes. Thank you. Yeah. So the secure part is when the data being recorded by one IoT device, we know it's from that IoT device, because the IoT device can have a security module that holds its own private key, so that the data is being signed by the transaction is being signed by the IoT device. So no one can maliciously fake the transaction.
besides the device manufacturer?
Exactly. And that compared to the traditional block, compared to other ways to upload the data, then you always have this kind of issue that if you are thinking about talking to Oracle, and a lot of people are using some voting mechanism to get the data. But if you use IoT, that could be a solution that you can be more trusted than the voting, because voting can also fake the result. I mean, not fake, but there's some incentive for you to misuse the voting in some way.
Is the device a node on the chain?
I would say it depends on their functionality. And it could be a lightweight client, it could be kind of a partial node, it could be a full node.
Okay, how do you identify a device on the chain? And if I temper, if I, malicious actor temper with the device, and then basically send data that's changed because I tempered the device, IoT device itself, can you verify that?
So I think currently I think
What you can do is you can do the remote authentication, see whether the device still behave as you expected, or is there any malicious code that be injected to the device from the firmware. That's what you can do. Other way, you can also build a decentralized identification system on top of the blockchain to manage all the IoT devices. It's basically two way. You can provide unique identity. You can also check the security status of the device.
What do you mean by unique identity? How do you design unique identity?
Yeah, that's depends on the functionality of your device. For very cheap device, at least you can get the digital certificate due to the manufacturer process. So usually the way it works, you have a device from your production line, and then you have the certificate authority to generate machine-to-machine communication certificate in the compact format. Then those certificates will be injected into your device during the manufacturer phase, and this certificate can be used to identify the device when they join the network.
How do you guys handle either two opposing events at the same time through like a large network, or if you have downtime and you have a severed blockchain of blockchain, how do you get a consensus back on which chain takes precedent?
That's a very detailed question. Can we get it back to this later? Yeah, because we have a lot of cover right now. Yeah. So right now we have a GTA to talk about our RDPoS, and we also have a demo and how it works. And later, CT will get into our privacy techniques. Okay. Yeah. GTA.
Let's go get into Q&A.
All right. Hello, everybody. This is Zhi from IoTeX. I'm the software engineer here. So Du has introduced a few innovations from the IoTeX, and in the next section, I'm going to provide more details about RDPoS, which is one of the biggest innovation for our blockchain. So just to be one step back before we introducing our RDPoS mechanism, let's go through what is going to be the consensus for the blockchain. Blockchain has the collaboration is about a set of nodes on different places, and they also having a copy of the ledgers on their nodes, right? They need to have some sort of agreement. They have record the same results, and they are going to take the same action. This is why we need to have a consensus. Different nodes in the network and talk to each other and decide this is the thing we want to do. I think the birth of the blockchain, the Bitcoin, we have invented a few consensus mechanisms, like the proof of work, like the proof of stake, and recently the delegated proof of stake. They have cons and pros here and there. They have a trade-off between the throughput, finality, decentralization, also of these things. And we do a lot of research, and we find that delegated proof of stake is the good choice, as it's going to have the feature to limit the consensus protocol just among us, a small set of nodes, so that we can reach the consensus quickly and provide a high TPS throughput for the applications. But on the compared to the proof of work and proof of stake, the traditional consensus methods. But on the other side, we are also aware of the delegated proof of stake has problems because you limit it to a small set of nodes, right? You are trade off the decentralization. This is where we want to put our innovation into. So at high level, what our RDPoS is we are going to choose a wider delegation pool, and among this pool, then we will have some algorithm that backed by the cryptography to guarantee we will fully randomly choose a small set of delegates to do the block producing. So in this slide, I'm going to highlight the 4 key components that we have for the RDPoS consensus. So the first of them is we want to choose who are going to be the block producer. So we need the block producer selection mechanism. This is through the delegate pool. So how the pool works? So for the first step is for a node participate into this network, it needs to issue an action to nominate itself to be the to say I'm willing to be the block producer, and all the participants, no matter you operate a node or you just own the tokens in this network, right? You can use your token. This is the power for you to vote who you want this guy to be the block producer. So there could be a lot, right? Hopefully there will be thousands or even tens of thousands of people are willing to be the block producer. But we just will have a short list, like for example, 100 or maybe 500 top block producers which have aggregated most of the votes. And within this small set of candidates, then we can select by using our cryptography algorithm to randomly choose a set of the nodes that will be the block producer for the apple. The apple, the concept we have introduced is that you can think of this several rounds of the consensus, and during this round, we will always delegate this part of people, this part of block producer nodes to run the consensus and produce the blocks for the whole network. Yep. So now we have how we figure out who will be the block producer. The next one is how these producers agree with each other. The mechanism we choose is the PBFT, which stands for the practical Byzantine for tolerance. So we implemented this consensus algorithm, and we have our own improvements to make sure it's going to reach the instant finality. That means once a block has been created, then the transaction is finalized. We don't have the chance that another block will replace this one, or we have a fork of the blockchain. So the third part, which is also pretty important piece of our consensus mechanism, is a random beacon. So this is some very hardcore cryptography stuff that is going to, you can think of, we're going to create some secrets and in each block, so that after a round of the epoch, we are going to accumulate enough secrets that's going to be able to determine the seeds and determine who will be the next epoch's delegate, so that we can make sure. So first, from epoch to epoch, we are always going to do some kind of switch from this group of delegates into the other group of delegates from the candidate pool, and also this will not be predicted in advance. And the last but not least part is, and Don also has mentioned, we have the root chain, side chain architectures. So our consensus is also trying to support this architecture. That's why we need to have a larger pool. And for this pool, we are not only going to select the delegates who is going to produce blocks for the root chain. It is also going to select from this pool the people, the nodes who will support the block producing for the side chains. So this pool could be pretty big, depends on the demands of the side chain, the whole ecosystem. So, question?
Yeah, so I just wanted to clarify, does that mean that the root chain will, creates the VPs for both the subchains as well, or do the subchains have their own governance over their own VPs?
So, I think both ways should be fine. What I would like to mention here is in this governance, we actually are talking about you usually start the side chain, and this side chain is also use the delegates, use the nodes block producer in this candidate pool to produce the block for your side chain.
So, two questions. First one is, how long is the epoch?
So this could be actually the configurable numbers. We are still doing the experiment to figure out how long the epoch should be in terms of number of PBFT rounds. That is the sweet spot for us. The idea is we want to have it to be longer because at the beginning of every epoch we have some sort of additional additional work to the cryptography work to determine the order of block producing in this epoch, right? This is going to take some effort to do. So we want to amortize it over the whole epoch. That said, the longer the epoch is and the smaller the overhead per block. But how long it could be, how long is going to be the most stable, almost reliable epoch, we're still in the investigation.
Fair enough. My follow-up to that, actually kind of related question, essentially. So it basically sounds like most other proof-of-stake implementations, except that the validator set is randomly shifting, right? So if the validator set is randomly shifting, what are the guarantees that shift when the transition happens? Basically another state change, right? So you go from state number 1 where your validator set is A, and you go to state number 2 where your validator set is B, and in the middle, if I was a device that last looked at the validator set A, I've suddenly entered a world where the entire validator set has changed. Does that mean now I have to download the entire history to validate this, to check if this is a valid transition?
I'm not sure I fully understand your question, but I'll try to rephrase. Are you actually talking about for different block producers, they may not have the consistent view of the current ledger so that they cannot reach consensus? Is this your question?
My question is, the pool of validators is shifting, right? That's what's happening here, right? So when the pool shifts, If I was a device that was on right now, then I went to sleep and I came back on in the morning and the entire set of validator pool has shifted, how do I get to a same state?
Yeah, so first of all, you like you have the phone, right?
Right.
Your problem is not going to be the candidate. So you are not clear about this, who is going to be the candidate. What you are going to do as a lightweight node, you are going to just passively listen to the block updates from the network. When you get online, you will seek the blocks from the network, right? And the thing is, we, for example, because of the network latency in on different nodes, you probably will. So for example, I got the block 100, you got block 105, and how do we know from block 100 to block 105? Because of the new transaction happens, the delegates will be shifting from this group of people to that group of people, right? So we have some deterministic way to make sure that everybody is going to agree on the same list of the delegates when started the new epoch. If you are interested in this, we can talk about more tech details offline, but that will be very detailed stuff.
So we're going to run out of time, so I want to make sure we get to knock it out, so go for it.
Okay, yeah, let's get to our demo, and if you're interested in more details, we can just chat offline. So in the last month, we have released our testnet alpha, and I would like to show our Explorer. And in Explorer, we have this sort of the RDPoS animation. It can give you the immediate concept of how this is working. So you can see in this testnet, we have set up 21 candidates pool, and for every epoch, we will nominate 7 nodes to be the block operator. We just see the shift from one to the new one. So another 7 nodes has been chosen as the block producer for this epoch. They are highlighted in purple color here, and the flashing one is actually the current block producer. We have some way to make sure they are going to take the turn one by one. Yeah. Also, we have a very cool Explorer. They listed some high-level blockchain metrics. Each individual blocks transfers and votes. If you are interested in, just go ahead to play with it. Sorry, how can I get back to the slides?
Yep, there you go. That one.
Oh, this is, oops. This one. Yeah. This is our Explorer website.
And that's your testnet?
Yeah, our testnet.
How long have you been live on testnet?
So we have been running this testnet since the end of June, and we will do testing from time to time and test the throughput and test new features. So sometimes we will restart and reset everything. Cool. So next, our Dr. Xinjing is going to continue the section about privacy technologies.
Alright, so I'm happy to share with you guys about some research we did a few months ago. Just some small project. Okay.
It's on slideshow. We want
oh. Okay, so privacy for blockchain, which actually is the focus for many blockchain projects you might be aware of. When talking about these issues, first is what's the motivation to consider the privacy on the blockchain. So initially, they have the Bitcoin network or Ethereum. All the transactions just post in plain text, and everyone can use Explorer to see what's the transaction, what's the source of and the destination of those transactions. So you may think you have a key pair, and no one knows who you are because that key pair does not associate with your identity. Unfortunately, if you conduct the traffic analysis on the blockchain network, you can actually build a traffic analysis diagram. When combining with some third-party information or some other context, it's not that hard to identify who sent those transactions exactly. So that's why people has a concern about privacy on the blockchain. Some people just don't want to leak those information to the public for different reasons. That's why we consider privacy also a very important aspect for the blockchain design. Especially as you know, the IoTeX blockchain also focuses on the IoT domain. IoT domain has very strong regulations, especially in Europe. You may know the GDPR got effect in the past few months, and all the IoT manufacturers, they are facing the new challenges how to be compliant with very strong privacy law and still can ensure the operation of their IoT device in the field. So basically for us, to solving the privacy issues have two aspects. One is on the blockchain side. If you think blockchain in a simple way, it's just a bunch of transactions. So you have sender, you have receiver, you have transaction value. That's the three components you try to protect. Okay. So on the device side, on the other hand, you need to consider how to protect the data collected from the device, how to be compliant with different regulations across global. So today, we will talk a little bit for the blockchain side. So as I mentioned, you have three components: sender, receiver, and the transaction value. You try to keep private. For current status, you usually have the different technologies you can play with to enable those features on your blockchain. For example, if you want to protect the sender's privacy, basically you are going to do is hide yourself among a bunch of people on the network. So the technology used there is called the ring signature. The idea is you send a signature on behalf of a group of people. So in this way, people don't know where this transaction comes from, but they know it's come from a group. You just hide in the crowd. Okay, that's for the sender side. For the receiver side, this is called the stealth address technology. So basically, you can send multiple transactions to the same destination. However, when someone observes the blockchain transactions, they don't know all these transactions targeted to the same person. Okay, this on the receiver side. For the transaction value, it's a little bit more complicated. Basically, you need to prove the relations between input and output. Also, you need to show the transaction is correct, and all the input and output is within a certain range, which usually using the technology called zero-knowledge proof. So that can hide the transaction value and at the same time prove the transaction is correct and private. Okay, so these are three components when you consider the privacy issues on the blockchain side. Today we will talk a little bit more for the receiver side. So I'm going to be talking about the stealth address designs, which is a popular technology that has been used in several blockchain projects to ensure the transaction privacy on the sender side. We may go over together for the evolution of this technology, which already have several iterations for the design. We will also briefly review what we designed, this dual key skills address technology for the IoT. The first part, we just quickly go over the evolutions for this privacy enhancing technology together. So the skills address is a privacy enhancing technology. So as I mentioned, it's used to protect the privacy of the sender on the blockchain transactions. So in a nutshell, this skills address, they require a sender to create the one-time and the random address for each transaction on behalf of the receiver. So sender will generate the one-time random-like address, and they send these transactions to those randomized address, and actually it's targeting to the same person as I showed in this figure. They send the transaction to a different address. However, it's sent to the same person. Okay. All those transactions are unlinkable if you observe the transactions on the blockchain. You'll see they are sending to a different address, and you don't know who the destination will be. However, some of the transactions actually sent to the same person. So all the skills address design based on the elliptical cryptography. More specifically, they based on the what they call the CDH protocol, elliptical version of Diffie-Hellman key exchange protocols. This protocol is quite simple. Everyone has you have a key pair, you exchange key pair with the other communication party, and I send public key to you and you send to me. I use my private key and you use your private key to doing the operations. And after computation, both parties get the same common secret. Okay, this key exchange. All the previous designs for skills address based on these protocols. So the first design is actually in 2013, 2013 around that time. It's called the Basic Skills Address Protocols, BSAP for short. So this protocol actually is quite simple. You can simply just directly apply the ECDH protocols on the blockchain setting. Both sender and receiver have the key pair. They just exchange the key pair. And both sides compute the common secret and apply the hash function to get a shared secret. So each time sender just simply use this common secret times base point on the elliptical and send the transaction to this destination address. So you can see this basic design has some disadvantages. The destination address actually is fixed since both parties the key is fixed. So this destination address is fixed. And both sender, so both sender and the receiver, they both know the private key. Here's small c here. Both sender and the receiver know this key. This key will be used to spend your token you receive from the other side. So if both sender and receiver know, which means the sender can get money back if you want. Okay. So this is the very first basic device. So the second one is the improved version called ISOP. So we know from the first schemes they use the fixed key on both sides. So the improved scheme, the idea is to use a randomized key pair. So on the sender side, you can see now instead of using his fixed key pair, he generates ephemeral key pair, R and R times G. The rest of the protocol just follow the ECDH. You compute the common secret and then apply the hash function to this one. However, for these protocols, each time you need to send the transaction to the new address, which is the common secret times this base point, plus the public key of the receiver. Yeah, you can see from here, each time sender chooses a different ephemeral key pair, the destination address will be different. So they will send to the transaction to the different address, which looks less random. Okay. We're almost there. However, this improved design also has some disadvantage. So in this scheme, blockchain node, they still need to use their private spending key, B here, for actively scanning the blockchain to see whether this transaction is sent to him. Okay, so in terms of the security practice, which is you can feel is not that secure. If you're constantly using, imagine you're constantly using your wallet key to send something, it increases the chance that this key might be leaked. That's why for important transaction, like the Bitcoin, you prefer the cold wallet. You store the long-term key in a very secure storage. Okay, but for this scheme, you can see they are using this private spending key to check to scan the blockchain transactions to see whether the transaction is sent to him. Okay. So this is the second scheme. So since we have this problem constantly using the private key, next idea is to we split the task. Okay, we have two key pair. One is using just for scanning the blockchain purpose to see whether this transaction is sent to me, and the other key pair is dedicated for spending. Okay, in this way you can put your spending key in the very secure storage and use your scanning key just for scanning the blockchain to identify which transaction is sent to you. Okay. That's why we have this dual key schemes. Each party have the two pair of key. You can see have the spending key and the scanning key. So when sender want to send you a transaction, they will still doing the electrical version key exchange, but instead of using your long-term public key, they will use your scanning key for this purpose. Again, each time when sender chooses a different R, you will get the different destination address, which you can send the transaction to. This version, is much better compared to the previous version. Okay, so I just skip this diagram. Basically show what they are doing. You can see for this type of steals transactions, besides sending the destination address or public key, the value you try to send, you also need to contain your ephemeral public key on the sender side you generated before sending each transactions. Okay. So receiver side, they just doing the key exchange protocols and the scanning blockchain to see which one is sent to me. But they need to scan every transactions. Okay. What's this used for in practice? Actually, they have a number of projects already using this or realize this in their blockchain systems. They have a couple of wallet applications like the Dark Wallet or the Samurai Wallet. They have a payment platform, TokenPay. They already also integrate this scheme into their payment platform. You may be more familiar with Monero. They exactly implement this dual key scheme in their blockchain to ensure the receiver's privacy. Okay, so this scheme actually works well on the Monero and other blockchain systems. However, when we consider our application, particularly for IoT, we are still facing some challenges we need to address. If you recall, you can see this type of skills transactions. You need a node to constantly monitor the blockchain, scan all the transactions to see whether this one is sent to me. They need to scan all the transactions. Well, this works well for the more powerful servers running on the cloud or more powerful nodes. It's not working for the IoT due to the resource constraint devices. You can never say the IoT device constantly doing something, right? It will run your battery very fast. So which raises our first challenge. So can we adapt the existing dual key scheme to the blockchain-based IoT systems by making certain trade-offs? Okay. So all the designs, whatever for security or scalability for the IoT, you always need to make trade-off. There's no free lunch you can play here. Also, the second challenge is the transaction. Use this stills address can be easily identified. Remember here, for those stills transaction, you have additional data you need to send. So, which means on the blockchain networks full of the regular transactions without enables privacy feature, and the transactions with this stills address feature enabled, you can easily differentiate between those two by looking at the additional data they are sending. So the second question or challenge we are facing is can we enhance the existing particles to further hiding the stills transactions. So the technology we are using, actually, I think everyone's quite familiar. If you consider the client server when they're talking, most likely, nowadays you all use the TLS. They have some very popular technology within TLS, which can be used to accelerate the access of the client to the server, okay, which is session resumption, which is a very popular technology here. Basically, you have two versions. You either can use session ID or use session ticket, depending on where you want to store that session information. So actually, we want to model this idea to our design. So for enable this idea on the dual key setting, actually you need to create some way to scheduling your key. Okay. So on the both sender and the receiver side, we have built this key evolution schemes. Basically, the sender will send one ephemeral key pair as the first initial transactions. So after first stills transactions, both parties get a shared secret. So instead of using a new generated ephemeral key for each transaction by the sender, both parties will apply the hash function to update this common shared key pseudo-randomly for a number of following sessions. Okay. This is similar to the session resumption techniques. I will skip this more complicated setting here, and I just want to give you the high-level idea and summarize what we are doing. Again, you look at these transactions. This is the first one, sending by the sender. They will send the ephemeral public key as part of the transactions. It's your first stills transactions. Later on, when this guy wants to send another transactions, they will drop this one, and because they will use this shared common secret for the following number of transactions. So the following one will look like a regular transaction.
So in the first transaction, the actual sender can be identified.
Yes, exactly. However, I want to make you realize, it's not free. So in this case, both sender and receiver, they need a small table to maintain the state for a number of rounds. Yes?
So you say that after they exchange the first, I guess, handshake, they compute the destination addresses consecutively after. So if the two ever get out of sync, then they'll just basically need to re-handshake?
Yes. If they lose the synchronization, sure. That's why we keep the status with the latest transactions they made. Quick summary. So this is what we did. All the sales transactions are divided into two categories. Depending on whether this ephemeral public is included in the blocks. So the receiver need to conduct same operations as the previous scheme, between the two blockchain nodes. And the sender will generate the ephemeral key, which only for the first transactions. And both receiver side, the receiver only doing the quick table lookup for the following transactions. Some security properties. We still maintain the properties for the receiver anonymity, which means for this scheme, if you still observe or monitor the blockchain transactions, you still cannot link two transactions which send to the same destination. Okay, we still maintain these properties. Also, we have the forward privacy, which means if an attacker compromise a device during your key evolution, they cannot trace back for the previous transactions. Of course, they can follow your future transactions if they compromise your device in the middle. So this is the one trade-off we made. Recall for the previous scheme, each time you generate a fresh key pair, whatever they compromise doesn't matter. But here, they can follow you for a number of following transactions. Okay. More subtle properties we provide here is to further hiding the stealth transactions. Remember the first one can be differentiated from the normal transactions. For the following number of stealth transactions, they are looks the same because you don't need to send that extra data as your ephemeral key. We did some analysis in terms of how many operations you need to do on the elliptic curve and how many hash functions computation you need to perform. And this is a comparison for the DOP scheme and IoT version. We wrote our own elliptical library. As you said, ECP283 K1. That's a curve used in some IoT standard. For example, the ZigBee Smart Energy specification. Okay, so we use all the optimization techniques to make it faster, and with some time information we tested.
Is the library open source?
We are still doing very strict code reviewing for this library, but later on. Okay, so this just give you an idea what we have done here. Similar to the TLS case, the overall cost of the IoT version is less than 50% of the original version. Also, you can save the transaction. Values. We can save this many bytes for the unconstructing transactions. So because we don't need to send the new ephemeral public key for every session. Okay, so in conclusion, we designed this IoT version of DOP stealth arrest schemes. The idea is to doing key evolution and extend the lifetime of the common shared secret. However, the trade-offs, both sender and receiver need to maintain a table for their state. So we can achieve at least 50% performance improvement compared to the original scheme. yeah, we also can have significant reduction for the transaction size for the block. Okay, that's all. Yes.
So if I ignore the rest of the chain and only look at records that include the ephemeral key, can I identify which receiver, because receiver is not anonymous in that one transaction, correct?
Still anonymous.
Right.
Yes, still anonymous. Because for that transaction containing the ephemeral key, the receiver needs to scan the blockchain to see which one is sent to him. It's the same as previous one. Yeah, but it's only for the first one. Yes.
That makes sense. Thank you.
Okay, so finally we are hired.
How big is the table?
So yeah, that's a very good question. For IoT device, you may think that's very resource constrained. And however, if you think about the typical applications like smart building, you may have the hundreds of sensors. Right? That table is actually quite compact for hundreds of nodes. But if you say you have millions of nodes, they both need to talk to the other millions of nodes. That's no way. But if you think how many transactions you are regularly send for in your regular life, you may send tens of transactions to your friends. Right? Yeah, you never can reach that millions of those transactions. So we think in the practice, in the real world IoT applications, and the capability of the current IoT device, we think is affordable.
All right, we got a few more minutes for questions because we're a little bit over. We got to clear up soon. So, any questions? How many people you guys hiring? Well, what kind of talent are you looking for?
Don't you want to?
Are you paying in tokens plus salary?
Yeah, that's basically the model. I think you guys are familiar with that. And also, in addition to that, we are also trying to get community developers as well. And because right now our blockchain code is open source, and if you are interested, look up the code and feel free to correct any problems and create a PR. And all the contributions are appreciated. And also, if you have a very big contribution, you possibly implement some of the big features, and we can also reward tokens as well. And also, we are hiring full-timers as well, and it's not very far. It's only 2 hours away.
Well, you guys in Palo Alto or?
Menlo Park. Very close.
Okay, that's 1 hour.
1 hour now.
Yeah. Yeah.
Cool.
All right, thank you, IoTeX.
To our
Oh yeah, no, this is yeah.